Happy learning! Today we're going to talk about two Eulerian circuit algorithms. And remember from our last video, an Eulerian circuit is a way to travel along all of the vertices of a graph without repeating any edges. Okay, so we're going to hit every edge exactly once. So today we will discuss two algorithms. For finding Eulerian circuits or trails. So in some case, we won't be able to find an Eulerian circuit, but we'll be able to find an Eulerian trail. Remember, a trail does not need to start and end at the same point. All right, so the first algorithm we're going to look at is called Fleury's algorithm. All right, and we're going to just walk through the steps of this algorithm. Okay, so what is the input in order to use this algorithm? We need a connected graph G. So our graph must be connected, and we must have 0 or 2 odd vertices. If our graph has 0 odd vertices, we're going to be able to find an Eulerian circuit. If it has 2 odd vertices, we're going to find an Eulerian trail. Right? We had a theorem that said that. Okay, here are the steps. And then we'll actually run through an example. Step 1. Choose a starting vertex. Okay, so we're going to choose a starting vertex V. So how do we do that? If we're in the case where G has no odd vertices, if G has 0 odd vertices, V could be anything. All right, it's literally up to you what you want V to be if we have no odd vertices. If G has 2 odd vertices, V must be one of the odd vertices. All right, so in order to complete this first step, we should find the degrees of each of the vertices in our graph. Okay, next step, we're going to choose an edge that comes out of V, and we're going to label it. Okay, so we're going to choose an unlabeled edge out of V and label it. And we just have to ensure that the graph consisting of only the unlabeled edges remains connected. Okay, and so that's basically it for the algorithm. So what we're going to do now for step 3 is we're going to travel along this edge and repeat this process. All right, so we're going to travel along the edge to the other endpoint, and then our last step is repeat 2 and 3 until all edges are labeled. Okay, so if we do this, we will either get an Eulerian circuit in the case of when we had no odd vertices, or we'll get an Eulerian trail if we had two. Okay, so the output of this is a labeled Eulerian circuit or trail. All right, so if you find yourself needing to find an Eulerian circuit or an Eulerian trail, Fleury's algorithm is a good choice. All right, so let me give you a quick example, and then we'll do a little bit more complicated of an example. So suppose our graph is the following. All right, so suppose this is our graph, and we wanted to find an Eulerian circuit or trail. First thing we need to do is find the degrees of each of these vertices. So this vertex has degree 3, right? There's 3 edges out of it. 2, 3, and 2. All right, so we are able to use Fleury's algorithm. We know that there will be an Eulerian trail on this graph. The first step, choose a starting vertex. If G has 2 odd vertices, which we do, V must be an odd vertex. Let's pick this to be V. Okay, so I'm going to just redraw our graph, and I'll build out our trail. Okay, so here's our starting point. We need to choose an edge out of V, and we just have to make sure once we label it, the unlabeled graph stays connected. Okay, so in this case, there's really no danger. We could pick any of them. So maybe we'll pick this to be our first edge. All right, so that's our first edge. Now we're going to, we're here. We have to pick one of the unlabeled edges. So I'll pick this edge. Label it. And we'll continue this process. All right, so now we're here. We can't use this edge. We can't use this edge. So we have 2 edges to pick from. Neither of them, if we use, it's going to disconnect the graph. So maybe I'll use the diagonal. And then here. And then down. All right, so our Eulerian trail, we'd go down, right, diagonal, right, and down. We cross each edge exactly once, and we didn't duplicate any. So we found our Eulerian trail. Okay, let's do another example. This one will be a little bit of a bigger graph. And with all these examples, I encourage you to pause the video. Right? This is the advantage of these YouTube videos, is you could pause them and try the questions on your own. Right? And then if you made a mistake, that's okay, because then you'll see me work it out. All right, so here's an example. Let's use Fleury's algorithm. All right, so here's our graph, and we want to use Fleury's algorithm. Okay, so go ahead, try this on your own. So pause it and then come back after you've tried it. All right, so the first thing we need to do is check, do we have 0 odd vertices, 2 odd vertices, or maybe more? So the degree here is 2, 2, 4, 4, 2, and 4. All right, we have no odd vertices. So we could pick anything to be our starting point. I'm going to pick this vertex to be our starting point. All right, so I'm going to get rid of our labels, our degrees. This is our starting point. Okay, and so I'm going to travel this way first. This is my first edge, and now I'm going to travel down. And why am I doing this? Because there's that one part of the algorithm that said make sure our graph stays connected, the unlabeled part of the graph stays connected when we select our edges. So now we're down at this vertex, and we have a choice to make. If we go up and to the left, back to our starting vertex, there's going to be no way to get from this part of the graph over to the unlabeled edges over here. So we cannot use this edge at this point. We need to get these edges labeled first before we could head on over to the left part of the graph. All right, and so what I'm going to do is maybe I'll take this edge, and now here, and now back down. So I'm back to where we just were. And now, since all these edges are labeled, I can travel back. And now there's just these 3 edges remaining. It doesn't really matter how we do it, but we did it. So here we have our Eulerian circuit. We start and end at the same point, and we crossed each edge exactly once, right? We go to the right, down, right, left, down, left, down, left, and back to the start. We did it. So the next algorithm we're going to look at is Hierholzer's algorithm. The idea with Hierholzer's algorithm is we're going to basically start with a cycle, and we're going to glue cycles, or we're going to start with a circuit, sorry, and we're going to glue circuits to our starting circuit to build like a bigger circuit. All right, that's the general idea. We'll see an example, of course. All right, so what do we need to use Hierholzer's algorithm? We need a connected graph with all even vertices. All right, so we cannot use this algorithm unless every vertex has even degree. So that's one of the downsides to this algorithm, where Fleury's algorithm, if we had 2 odd degrees, we could still use it. All right, so the first step is we're going to choose a starting vertex V. Which could be any vertex. And then what we're going to also do is we're going to find a circuit out of V. It's not going to be an Eulerian circuit yet, but just any circuit out of V. Okay, so in our example here, which we're going to actually work through the same graph in a second, if this was V, our first circuit could be this region down here. Okay, that would be find a circuit originating in V. We're going to call this, call it C. All right, so we have a vertex, and then we have some initial circuit. All right, the next step, which is the majority of this algorithm, is find a vertex on C. So find a vertex on our circuit that has unlabeled edges, has edges that are not in C. So find a vertex x on C, or if any vertex x on C has edges not appearing in C, we're going to find a circuit we'll call C prime starting at x. And this circuit is going to use two of the edges that did not appear in C. Okay, so for instance, we'll do an example, but if C was over here, our initial vertex has some edges out of it that were not in C, so then maybe we'd find another circuit. So it would be like C and then C prime. Step 3 is that we're going to combine C and C prime into one circuit. And then step 4 is we're going to repeat step 2 and step 3 until we get every edge. All right, and if we complete all of these steps, what we get is, again, a labeled Eulerian circuit. Okay, let's work through an example, and then we'll work through this bigger example. All right, so suppose our graph is the following. All right, suppose this is our graph. We could check each vertex has even degree. Right, degree 4, degree 2, degree 4, and degree 2. Those are all even numbers. And so how does this algorithm work? Well, we pick a starting point. And so maybe this is our starting point. And so we need to find a circuit out of this starting point. And so remember, a circuit just has no repeated edges. So maybe we go all the way around. This would be C. All right, and then we check, are there any vertices on the circuit that have edges out of them that were not in C? And yeah, this vertex and this vertex both do. So that would play the role of x in step 2 here. And so we would, let's say this is x. We need to find a circuit out of x that doesn't use the edges from C. And so that'd be down and back. I'll draw that in black. Okay, so black is C prime. And now the last step of the algorithm is to put these together. And so what we could do is, so we said this is what x was. So when we get here in our circuit, we're going to take a detour down C prime. So our first step is going to be 1, 2, 3. Now we're going to take a detour down the C prime circuit. 4, 5, and then down is 6. Okay, so this is how Hierholzer's algorithm works. We get a bunch of circuits and then we glue them together. Okay, let's use Hierholzer's algorithm on our graph here. All right, and so I could erase our steps here. All right, and so let's redraw our graph with none of the edges, and we'll let this be our starting vertex. So the first step was to find a circuit out of our starting vertex. Let's do this circuit down here. All right, we have to check all of the vertices in our circuit. Do any of them have edges that were not in the circuit? And yes, V doesn't. So we need to make C prime out of here. And maybe this is C prime. All right, step 3 was combine them into 1. So it was 1, 2, 3. Now we'll take C prime. 4, 5, and 6. And we check, are there any vertices in this graph that have edges that are not included? Yes, 2 of them. So let's go from here. We need to find a circuit out of here. That's, let's move this label to here. That could be up, right, and right. All right, and so now we're ready to change the labels again. So we got here with 4. This is going to be 5, then 6, 7, 8, and 9. Okay, so the circuit we found using Hierholzer's algorithm is here, 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 across, up, right, left, up, and to the back to start. So we did it. All right, so these algorithms have their positives and their negatives. This one is nice if you have a circuit and you want to build off of it. Like maybe you're learning some information about the graph as you go. Fleury's algorithm is nice if you want to do an Eulerian trail, right? This one you can't do the trail. All right, well, that's all I have for today. So let me know in the comments if you have any questions, and I will see you with another video tomorrow. All right, take care. Bye-bye.